Hey everyone, this is Michael from H2X. I am now recording the deep dive video for the ventilation system design in 10 minutes video. Put that in plain English. I'm going to explain every step that I took in that process and why I took the procedures that I did. So why I did things in the order that I did, and yeah, hopefully this can be helpful either for existing users of H2X or anyone looking at the platform as a possible solution for any issues with your design processes. Now, if we get started, I'll just go into the first part of the process, which was placing the AHU. So when you're selecting the AHU from the drop-down menu, you have 6 different options. Indoor AHUs have a intake and a supply outlet. The MVHR has intake, exhaust, supply, and extract, and outdoor simply has a supply. However, each of these units can be changed to match the other one. So, for example, on the outdoor, I can add an intake, I can also add an exhaust and a supply, and I can also rename this to match whatever I need. So, if I just wanted to change that to AHU, I could. The off the drop down options are simply different configurations of the same piece of equipment. The W/H/C means with heating and cooling. So if I select one of those, you can see that that comes with a heating and cooling connection that can be added to a heating or cooling design in H2X. This also brings a number of other factors into the actual design menu on the AHU here when you click onto it. So if I go back to ventilation, you can see that we have our heating and chill tabs. And I'll run into that in further detail on the process when I start to design the actual system. Now, if we take the unit with MVHR, back on the ventilation mode here, we can rotate it using the rotation arrows on the menu on the right hand side. We can also change the specifications. Now, on the video, I mentioned that I might need a larger unit based on the size of project that we're currently designing on. Now, that's because well, the reason that I mentioned that is because H2X won't specifically choose a unit for you. It will simply tell you the required fan duties and selection parameters for the plant itself that you would then go and use to select a piece of equipment to suit this project. On the specs menu, you can change the depth, which is the width in relation to the inlet and outlet points, if you want to treat it that way. The height, meaning the Z height in the 3D. So if I switch over to the 3D mode, that is how tall that unit appears in the 3D, and obviously where the connection heights are relative to it. So if I change that to 1500, you can see that that goes a little bit taller. Height above floor will do exactly that. It will change the bottom of the unit's height above floor. So if we say that that's 500 mil above the floor, that will now appear as if it's placed on a plinth. Now we turn 3D off for the moment and click back onto the AHU unit. We can also rotate it and flip it from right to left, and that's how you would change the inlet and outlet location. So you change supply to the left and extract to the right. Now, if we move on from there, we can now begin to draw the duct runs. Now, in the video, I went straight into drawing my main branch or my main trunk run. And the reason that I do this first is because it allows me to set up the initial run for my system design. So if I bring that up to say 1.7 meters, you can see that that'll give me a little black horseshoe indicating that I've come out at 1 meter above floor on that unit, and then I've risen up to 1.7 meters, and then I'm now going horizontally across the screen. Every time I do a left click, I can change direction and I can change height. On the video, we only went in 90-degree directions, but you can do 45-degree angles, and you can also hold shift to give you any specific angle that you want. Now, to connect between floors, you place the riser here. Now that is currently connected at 1.7 meters above the ground floor, currently positioned at 0 meters absolute height. Level 1 is at 4 meters above the ground floor. And when I draw a main trunk off of this point here, that's now running at 1.7 meters above the level that I'm currently on. Now, if you were to accidentally run that at the incorrect height of 1.7 meters, we can actually click on the duct either in 2D mode or even in 3D mode, because we'll get an indication that it is quite low. See that that's our blue center line for our duct. But we can click on that when in design mode and it'll bring up our height above floor parameter here that we can easily change back to 3 meters. And it's quite easy to go through the system and select the elements that you want to change. They're now running at 3 meters above the floor. If you want to see how that relates to the ground floor, go up to the level visibility menu at the top here and just turn on all levels. You also have the ability to turn off things like the calculated, well, load rooms, so that you simply see the system design as it's laid out on the plan. Okay, now we started on the ground floor in the first example, or on the 10-minute video that would have been linked back at the beginning of the, well, back at the start of this video. But on this particular project, we'll start on the upper floor. Now, following the main duct run, we can then use our individual branch connections to run into each of the individual office spaces. So left click there to begin, and then left click every time we want to change direction or change height. Placing the diffusers is a simple case of clicking on the diffuser drop down menu here and selecting the shape and orientation that you want to use. If we go for circle horizontal, that's a circular grill or circular diffuser pointing down. If you go for circle vertical, it's the circle diffuser pointing out, sort of horizontally, if you were to look at it in real life. Now, for this example, I'm going to choose the circle horizontal, like I did in the 10-minute example, and I'm going to align them by hovering them over one another. So I'll hover this diffuser over this one to get the blue crosshair here, and you can see I'll get a dash line to indicate that I'm keeping that nice and in line. You'll see that that splits the fresh air load of this room, currently calculated on the number of people in there that I've manually inputted on the load calculation process. And that will split itself by the number of diffusers that are placed in that room. We could click on these diffusers and alter the breakdown of how they pick up the load for the building or for the room. If I change them to share units, they'll take an equal share of the entire building load. And you'll notice all of the rooms then turn green because the fresh air is being shown as being supplied through these diffusers. If we switch over to manual, that's how we set up a manual load, where we can say that we want so much flow rate running through each of those diffusers. So I think it was 48 liters per second in order to meet the load demand of that room. Now that should update itself and turn green. But if I switch that back over to room, they will not change, they'll just split the 96 between them. Now if I do a right click and drag, that'll allow me to select more than one element at once. Right to left selects everything the box touches. Left to right selects everything inside the box. You can see I've only got that section there. If I go from right to left, it gets this additional branch as well. To copy that, I can hit copy and paste on the menu at the bottom. Or you could simply use Control-C and Control-V, similar to programs like AutoCAD or Revit. I'm going to add in the diffusers into each of these office spaces now, using those same procedures. And you can see that following those procedures that I've just mentioned, it can make the design process quite slick and easy to do. And if we did want to make any alterations, it's very easy to just select these ducts, move them along, change them, chop, change them. And if we want to select, copy and paste this element here, we can very simply do so. So left click there, drag that into place there. I do want that to be a little bit further up. And I want this to connect as a branch through here. Connect onto there. Now that's how to run the different ducts only. Now to add the different dampers and valves, they can be selected from the drop down menu up at the top here. So smoke dampers, fire dampers, VCDs, attenuators, each element that you place will have an associated Zeta value, which will be used to calculate the pressure loss based on the calculated duct size and the calculated velocity through that section. That is also done through the fittings. Now, if we click on this fitting here, we do have the ability to alter the Zeta coefficient before we run our results. However, depending on the setup from the system settings, H2X will select a default Zeta value based on that fitting size and shape. So if we go onto it, you can see we've got a Zeta value of 0.15 for that smooth smooth circular bend on there, or smooth round bend, however you want to term it. Now, all of those default parameters can be changed in the system settings for branches, connections, mains, and the different fitting types associated with them. So if we click on settings up in the top left and go over to supply, you can see here that for my supply ducts, for my mains, branches, connections, and also risers, I can choose my default duct material, my default duct shape, my minimum duct diameters or widths and heights, and also my target width to height ratio to be used. If I scroll down a little bit further, I can set my smooth elbow settings, my circular elbows, rectangular elbows, what they're going to be made from, of the different denominations. And there's also some additional T settings in there. But for example, if I go over to my mains, I can switch all of these over to shoe connections on my horizontal ducts for those that are rigid. And if I go back to the project, recalculate this, you can see that that adds those shoes or boot connections into those different locations, and it'll also alter the Zeta values to suit based on those changes. If you want to make an alteration to a particular duct on any of those runs, you can see that that is currently 500 by 250 mil high based on the 2:1 ratio. However, if I select that, I can go to my technical menu and I can change around the material, the size, the shape, and have that fixed to whatever element I want it to be. So if I change that to let's go for a much smaller duct, let's go for a 200 mil diameter duct. I'll rerun my results. It'll add in the appropriate connection pieces, and it will also indicate whether I have higher pressure drops, higher velocities by using the associated heat maps for those different flow system types. So I'm currently on max velocity. I go over to my filters, I can show that parameter here, and I get the indication that I've got a much higher velocity in this area with the smaller duct because I've reduced it down. Now, going through some of the results in more detail, as we mentioned, we can show the Zeta values at all of the fittings. We can also show the pressure drop through each of our grills. All of these other listed parameters here. The index node path calculation is automatically identified based on the pressure loss through said index node path. Now, currently we've got our heat map turned on, but you can see I've already got my index node path showing. It's currently going through this diffuser here. If we were to make any alterations to this design in the setup or the orientation or however it's put together, H2X will automatically calculate the change in that index node path. So let's imagine that this, for some reason, wraps around the back of these two rooms. Next up here. Get rid of that, rerun our results. H2X will automatically re-identify the index node path. And then if we go back to the ground floor, see that we've got a changed supply fan duty. If I undo that change, then recalculate, you can see that my pressure drop automatically changes on there. Now, when running ducts alongside other ducts, for example, if you're running an extract or a return alongside your supply, it's very important to draw that in relation to the heights that are shown. So you can see I'm going in at the 1 meter, can bring that up to 1.7 meters, running adjacent, that should be absolutely fine. And then we can run that upstairs in the same fashion. Now, when we're drawing out of this duct at this level, we need to make sure that we don't clash with our 3 meter duct height here. If I bring that up to a higher height of say 3.4 meters, we will be able to avoid that without having to make any changes in height. We'll bring that across, we can wrap that around and do whatever we need to. However, if we did want to avoid this duct here, you can see that the height is shown on it. So we can say that, okay, if we need to go below it, we'll have to go down to say 2.6, bring that underneath, type in H, bring that back up to 3.4, run that into here. Now if we add on a grill on the end of here and manually size it based on manual load, so if we put 250 litres per second through that, run our results, H2X will account for those two additional bends, both in the 3D and on the 2D for the calculations. And we can see exactly how those systems interact running through that system design. If you want to make any alterations, we know that we can bring that up to a larger height. We just need to click onto it in the 2D mode, back in design mode, bring it up to a height of 3.4. Rerun our results. H2X will get rid of the 2 or the 4 additional elbows dropping down and coming back up, and that will recalculate the index node path resistance for us. Okay, now we've got our results from the system design. Let's have a look at what we can take out of H2X. Obviously, the PDF drawing set can be created by selecting the PDF option off the drop down. You'll then be able to select an appropriate paper size and scale, choose which details you want to be shown on the plan, and also the size of that detail. So if I turn on our duct sizing only, increase the size of that detail, you can see we have the ability to edit that and change the way that that will visually look on the plan. We can turn off the H2X load rooms as well. We can change around the transparency of the uploaded PDF. That way, if you had any details that you didn't want to be shown, you could turn that off. They can also be cropped. On the PDF page here, you also have the ability to add your own company logos, details, and you can change the entire layout of that title block. That way, when you do export it out of H2X, it will appear as it would on your current exports. If we go over to the schedules up at the top here, you also have the ability to add your grills based on the size, pressure drop, velocity, flow rates, and level that they've been placed on. Now, if we export this for this level only, that will download as a PDF drawing set that can be distributed to whomever might need to review it. You can see that's what an example design would look like. If we go over to go off 3D now and go over to export, we can also take out our design report, which will give us a full breakdown of the calculated results for that ventilation system. Now, if we click on our ventilation export here, we'll have a breakdown for our AHU, our sizes, our ratings, our fan duties up at the top. And we'll also have a similar breakdown for our dampers, fans, our ducts themselves, our different fittings, so all of the associated Zeta values and the pressure drops based on the different either through routes or bend routes. And we can also order them in the index node path. So you can see the end diffuser and all of the ducts, fittings and dampers that make up that static pressure loss calculation for the fan duty sizing. We can also take this project out of H2X and into a AutoCAD or Revit model. We can generate those using our external plugins. However, I will leave that to other videos that are in our library at the moment. If you'd like to see this process applied on one of your system designs, feel free to reach out to us. I'll leave the link in the description to our website where you can book in a demonstration with our team. It might be myself that runs through that project with you. So yeah, hopefully I'll see you soon if you are interested. If you found this content useful and you'd like to see more, please consider subscribing to the channel or leaving a like rating. It really does help the channel in these early days. And thank you for taking the time to watch, and I'll catch you later.